Okay, today we have a ring right here. It is unmarked and it's a white metal. Okay, it's a white metal. So right out the gates, what I want to do, I want to look to see if there's any home markings that have been polished off. All right, want to look at the metal. Okay, the next thing I'm going to do is I'm going to get a neodymium magnet, and I want to see, okay, does it have any magnetism, right? Is it slightly magnetic? And it is. So if it was steel, it would have a very strong pull, right? Like that. This isn't. And so I know what this is because I come across it a lot. We must understand why this is magnetic is because when you plate brass, you must first put a barrier metal in there, okay? Now that's nickel, okay? And nickel, it prevents oxidation of the brass. And when you plate brass and you nickel plate it, the gold, you then use electrolysis, and it prevents, pitting, and it acts as a barrier metal, so there won't have any diffusion or anything. Okay, so what is yellow brass? Yellow brass has a density between 8.3 to 8.6 grams per cubic centimeter, and yellow brass, an alloy composed of copper and zinc. Okay, so I have some keys right here, right? These are all brass. They may look white. You can see some of the keys. The plating is bleeding through. Okay, so brass, an alloy of copper and zinc, is not magnetic, but when you have a nickel plating, you can see here it's very slightly magnetic. Okay, see. Okay, so you guys kind of get the idea there. So what we're going to do is perform a density to demonstrate that I should have approximately that, because the base metal is brass. And you'll see this. So here we go. We have a weight here, 2.12. You can see that. So we wrote that down. And now we're going to obtain the density with water. Okay, so we will tare that scale. We're going to be using a very fine string. Make sure that the scale is tared to 0. And agitate it a little bit. And we have 0.25, as you can clearly see right there. Okay, so 0.25 grams. Here is the result. We'll plug this into the calculator. So we take 2.12 divided into 0.25. It comes up 8.48. Okay, so 8.48 grams per cubic centimeter, as expected. Okay, as expected. Okay, we're getting an understanding of how this process works. Demonstration with the yellow brass keys that are nickel plated to prevent oxidation, and we've obtained that with the density reading. So what I'm going to do is just clean this ring off. Then I'm going to use magnification to see if I can see any type of pitting or any type of bleeding of the metal here. And I found it. Here it is. You can see this right there is where the brass is bleeding through. And this is just a very thin layer of nickel. And this was silver plated. Okay. So from time to time you come across a lot of this stuff in the secondary markets, you know, things that are hallmark 925 and they're nickel plated and they're electrolytically silver plated. Okay. So using a density test is really great. Now, if I put nitric acid on this piece, it will instantly turn green. Okay. Whereas on a silver piece, it will turn white from the silver nitride crystals forming on the acid. So here's a piece. We know what it is. Okay. That right there is indication it's not picking it up. Very strong pull. So we give it a little scratch on the touchstone and, look within magnification. We can kind of see that, yeah. So, hope you guys learned something, and that is that.